All right, cool. So here we are with our first session with Prashanth. You guys can hear me, I assume.
Yep.
Okay, awesome. So yeah, as I said, a lot of people, developers, do not pay attention to Bitcoin. They think that you can't really build on top of it, and they just move on to Ethereum or other blockchains, which is not true. You can build on Bitcoin, and the most exciting part that's happening right now in Bitcoin is the Lightning Network, and that's why the session is called Introduction to Lightning Network, as and why developers should pay attention to it, because that's if you learn about it and if you get a better picture of what's going on, then I think you can take a good call on you if you want to work on Lightning or not. And so here we have Prashanth, who is the CEO of Lastbit. And Lastbit is one of the few startups from India who's actually working on Lightning, and they're doing some amazing work. They have a wallet for Bitcoin, and they also are coming up with a Bitcoin debit card, which is pretty awesome. So yeah, Prashanth, the stage is all yours.
Thanks for the intro, Shekhar. Hey guys, it's nice to see so many of y'all turn up for this developer meetup. So let me quickly share my screen and start off. Right? Can you see my screen? Let me know when you can see my screen. All right. Good. Okay, great. So let me start off. Let me start this off with like just a quick introduction to myself, what my company does, what Bitcoin is, and what Lightning is, and it's going to get. I mean, it's really not very technical. It's since it's a developer focused meetup, try to keep it as high level as possible. But I hope that this actually evolves into a future series of meetups that can really go very in depth into several components of the Lightning network and Bitcoin in itself. So small fact is we actually just set up our own Bangalore office here, and we'd love to be able to host these developer focused meetups in the future as well. So so Lastbit, I mean, I started Lastbit about 2 years ago, and one of the fundamental problems that we really wanted to solve was for Bitcoin and cryptocurrencies in general, that you don't do anything with them. I mean, looking back at Satoshi's white paper as well, like one of the first primary, like one of the most fundamental things was this is meant to be a peer-to-peer electronic cash system, and this is what we believe, and this is what we want to see for Bitcoin and cryptocurrencies. So, like we want to see this happening. But there are many fundamental challenges before you can actually make any of this happen for the masses. Like I see there's plenty, like Shrikar said, there's plenty of great products coming out, like plenty of great new ideas, protocols and whatnot, built on many different cryptocurrencies and various blockchains. But at the end of the day, the number one issue, like the absolute single fundamental problem, is that if this thing is such a great idea, at the end of the day, if you have 10 or 20 million users, none of these blockchains, not a single blockchain can actually hold up to what it says it does in actually the same way that Bitcoin does. And the only answer to any of these questions is the test of time. So Bitcoin, as Shrikar said, was also like obviously is one of the first. It was the first cryptocurrency, and that's what inspired every single other shitcoin and everything you have today. So it's basically stood the test of time from 2009 until 2020 today, and there's literally nothing that's been able to shake it, including governments and all sort of powerful parties that you can imagine. So so just a quick story into Lastbit and why we find this problem actually really exciting, and why actually developers would ideally find this exciting as well is, well, especially being of Indian origin, like when I was studying abroad, I had the chance to actually like, travel around Europe, and when you try to go around and pay with different currencies, and you have an Indian bank account, you spend a ridiculous amount of money just converting between different currencies, and crypto is sort of the ideal solution to this problem, if one would think so. But at the end of the day, none of these. I mean, this thing basically cannot hold up to its promise. The simplest solution in this case is you basically give up control of your Bitcoin, or you basically put it on an exchange or somebody else's service, and you tell them, hey, I'm going to give you my crypto, you control the whole thing, and then you're going to give me give me the local currency in return for a small fee. This sort of defeats the entire purpose of Bitcoin and crypto in itself. I mean, you would just be better off trying to open a regular bank account, right? So the first problem that to solve is like, how do you stay in control of, how do you like get all the benefits of Bitcoin? Basically, it's decentralization, privacy, and that's your keys, and you control everything, and at the same time be able to use it as a regular currency. So Lightning is actually one of the most elegant solutions, and probably the most exciting thing that's happening with Bitcoin and crypto in general. It's literally like the evolution of the internet. And like little well known fact is that it's not as advertised as a lot of the other companies, mainly, I mean, a lot of the other products and shitcoins you have today, mainly because there's no company backing Lightning, or there's no marketing team for it. Basically, it's mostly pure interest from people that actually look into it and see, oh shit, holy shit, this is pretty exciting. So I'm hoping that I can sort of get you guys excited about it today. So as I said, the number one, the most fundamental problem is, like, I'm going to start off with like the Bitcoin basics. And like the fundamental problem with all blockchains, which are mostly similar to Bitcoin, is that it doesn't matter what amazing products you have. At the end of the day, if 10 or 20 million people start using it, it's going to break. Like literally what you saw happening when the whole ICO boom happened, and then like all the prices were skyrocketing. Like the Bitcoin transaction fees were ridiculous. That's because that many people were using the network, and the fees just inflated to keep the network up. And that's the problem. If it does happen again, it's going to sort of like destroy the name of cryptocurrencies. But luckily, we have some good solutions for it. So, for example, let's take like the traditional coffee cup transaction, right? Okay, I'm this dude. I'm a guy, Bob. I want to buy a cup of coffee. I want to pay for it with Bitcoin. So the first thing I do is I create a transaction. I take, let's say I want to pay 1 Bitcoin for this coffee. So let's say I take one of my previous transactions that has two Bitcoin, create a new transaction, sign it, have one output that goes to a coffee shop, one output that comes back to me, and then I broadcast this to the blockchain. So now every single, the first thing I do is I send it to my local node or the service that I'm using. That node would verify that, hey, this transaction is valid. Bob has the funds to spend this transaction, and then it includes in his local mempool, and then it propagates it to the next node, and so on and so forth. So at the end of the day, um, when you broadcast a transaction on the Bitcoin network, it propagates through the entire network, and it may or may not get included in the next block. So at the end of the day, when you're waiting for your coffee, it could be relatively cold by the time you get it. And this is not what Bitcoin stands for. You can't go to a shop, pay for a coffee, and wait like up to an hour to get it. To get your coffee, right? So one of the most, I mean, like this was like a pretty big debate a few years ago about trying to solve this problem of like, okay, how do we make these transactions faster? How do we make it instant, right? And one of the most commonly used comparisons is you take a traditional payment processing network such as Visa or Mastercard. So these guys can process up to 47,000 transactions per second at peak, is what the numbers say. But if you linearly, like by brute force, you say that, okay, well, let's take Bitcoin and stick it to Visa and like try to make it do the exact same thing. That's going to be about 8 GB a block. Um, and that's going to be about 4 TB of new data generated every single year. And just think about the number of miners that would actually be able to handle, I mean, to be able to devote the computing resources to handle such a network, right? And this would lead to basically a handful of miners that make the entire decision, and Bitcoin basically implodes on itself. So it's clearly not the right solution. And taking that down a little bit, like make it a little bit more realistic. If you basically try to assume that every single miner that's, let's say, like 10,000 nodes today, each of these guys buy, let's say, a 1 TB hard disk every single year, and they do this for a few years. At max, you cap it 500 transactions per second, and then it takes about 2 milliseconds to verify a single transaction with today's hardware. That basically cuts that down to 200 transactions per second. And network and bandwidth latencies are problems that we can't really solve for yet. And that reduces, again, that brings your throughput down to 100 transactions per second. And playing around with the block size basically fiddles around with this number 100. So the size of a block is sort of the least of your concerns before you can fix all of these other problems. So trying to scale a blockchain linearly is probably not the smartest thing to do. And as you've seen, there's quite a few ideas that have come up to attempt to solve this problem. And this graph on the right basically shows you the delay per size, the number of seconds per kilobyte in time that increases as you increase the block size. So it's very clearly evident here that as you continue increasing the size of your blocks, the amount of time it takes to propagate these blocks across the entire network just it increases linearly. And at the end of the day, if you're gonna have a longer propagation time for your blocks, you're gonna have severe forking in the network, which is gonna again implode Bitcoin. Like if the network sees a particular version of the network and the other side of the network does not see the latest block that's been propagated just because of the propagation delay, you're gonna have many forks. So Lightning in itself builds upon this very simple concept of. So Lightning itself is actually very simple. It's sort of like Bitcoin, which is not like a ridiculous invention of technology, but rather a unique combination of economics and incentives. So Lightning in itself has similar fundamentals, which is what makes it exciting. And one thing I like to really clarify is that a lot of people try to, when they classify Lightning in the bucket of protocols, and that's what from ICO. Like, so Lightning is not a shitcoin. It does not have its own token. It's none of these things whatsoever. It's just a very cool idea that a few people came up with, exactly the same way Bitcoin evolved. And the idea for scaling Bitcoin has been, I mean, it's just built upon these traditional, very simple architectures called payment channels that have been spoken about since 2012, so like way before Ethereum, way before any of the other coins came out, basically. So Lightning is just a very, very mature version of these basics that I'm about to tell you about today. So let's break down a payment channel. Like, let's take the example of me trying to buy that same cup of coffee, but now I want to try to make my transaction instant with this person and not have to wait. Not have to wait 1 hour for every single coffee that I buy, right? So a simple unidirectional payment channel where I am paying the coffee shop works like this. So now let's say I have 2 Bitcoin and I want to pay for this coffee now. What I'm going to do with the coffee shop is establish what's called a payment channel, and I do this by creating a shared account, a multi-signature address between myself and the coffee shop. And what I'm going to do is I'm going to take one of my old transactions that has, let's say, 2 Bitcoin in it, and I'm going to lock up this 2 Bitcoin in this multi-signature address with the coffee shop. So well, the simple setup is like, I'm going to go to the coffee shop and be like, hey, give me a public key. I take this public key, I create a multi-signature address, and then I lock some funds up in it. The first thing is obviously like, now if the coffee shop just goes offline and runs away forever, my 2 Bitcoin is locked up and I can never redeem it without a signature, right? So what I do before that is I create a simple refund transaction using the transaction ID of this multi-sig output, and I get that signed from the coffee shop first before actually confirming my setup transaction on chain. So in this particular case, I create this refund transaction first, get that signed, and then I broadcast my setup transaction, which is this multi-sig transaction, to the blockchain. Now, so this is the only transaction this is one of 2 transactions that is basically on chain, and everything else happens off chain. So now that, like, so before I go to the coffee shop, or let's say at the beginning of every single week, I would maybe set up a new transaction to create a new channel with this coffee shop. This is a very trivial example, just to illustrate how payment channels work. So once the transaction has been set up, now I go into the coffee shop. All I need to do is now say, okay, hey, I want to buy a coffee for 0.1 Bitcoin. So we're going to take that same setup transaction that we have here and just modify and create a new transaction that spends the output of that setup transaction and creates 2 new outputs. That's basically one output that reflects my balance and one output that reflects the coffee shop's balance. So that would be 1.9 and 0.1 in this case. That's the first commitment transaction, as you see there. In this case, this transaction does not have to be broadcast to the Bitcoin blockchain. It's signed by both of us. It's completely valid. But the coffee shop just takes it and puts it in his back pocket, because in this case, like, what the problem is trying to solve for is basically that when 2 people when 2 people are trying to transact with each other, these are the only 2 people that need to be involved in the transaction. The entire network does not need to know about it. That's the premise of Lightning and how it's built up. So in this case, we're just going to keep exchanging transactions until the point where we decide, okay, hey, cool, I'm done buying coffees from you, I'm going somewhere else, and you close that transaction, and you close this channel, and you create one last transaction that basically reflects the final balance between you two. So let's say I go to the shop 3 times, and then I buy coffee I buy 3 coffees, right? So at the end of the day, my balance is going to be 1.7 Bitcoin, and the coffee shop balance is 0.3. So until this point, all of these transactions are signed and all valid, and only this last transaction is broadcast to the blockchain. So the only thing that the Bitcoin blockchain sees is that initial setup transaction and the final teardown transaction. So this is a very, very basic example of what a unidirectional payment channel looks like. As you can see, it has many fundamental limitations, right? So you can only go in one direction. So you cannot go backwards. So for example, if a coffee shop had to give me a refund, how can I, like, there's no way that I can trust that the coffee shop deleted one of his previous states, because if he has a valid signed transaction for the previous state, he can still broadcast that and get a balance that's more favorable for him, right? So you cannot provably delete a state. So these sort of payment channels, this trivial architecture is limited in a single direction. And the second limitation is that,
Hey, Prashant.
hey, yeah.
Sorry to interrupt, but a few people are asking you to go a little bit slow because they're not able to catch up.
Oh, sorry. Okay.
Yeah. Okay. Cool.
All right, sure. Yeah,
Yeah.
I'll try to slow down a bit.
Cool. Cool. Thanks.
All right, so picking up on the payment channels again, right? So when you're basically making this, so like, just to recap, like a quick overview of what just happened is, so I'm going to go to a coffee shop, I want to buy a cup of coffee, and the only 2 people that are involved in this transaction are myself and the coffee shop. There's nobody else that needs to know about all my day-to-day transactions, and that's sort of the premise of how this whole thing is built. So what the first thing you do is you set up this simple multi-sig address, and I put some money into this address, and I tell the coffee shop like, okay, this is my deposit for buying coffee for you from you for like the next 1 year or whatever. So you can imagine, like at today's price, if you put in like one Bitcoin, that's $10,000. That's a lot of coffee. So you essentially lock this money up, and then every single time you buy something from the coffee shop, you would just basically give them a signed transaction that spends the output of the multi-sig transaction that was mined on chain. And then in this manner, you just keep continually exchanging these series of commitment transactions until the point in time where you want to say, okay, I'm done with this. I want to close the channel. And then you basically just update the latest state or the last known balance to the blockchain. You push that to the chain, and then the coffee shop's Bitcoin wallet has their all the Bitcoin that they're owed, and you have all the Bitcoin that you're owed. So that's not how the payment channel works. And two of the, like I was talking about, two of the fundamental limitations of this is that, as you can clearly see, you can only go in one direction. You can't go backwards. So if the coffee shop owner had to give you any money back, it's practically impossible, because in this case the balance would be lower for the coffee shop and higher for you. But you have already given him a signed transaction that has given him a higher balance, and he can just broadcast that to the blockchain at any time and get more money, right? So he's basically cheating you of your money. So there's no way to go backwards. You can only go in a single direction. Hence, the you need original payment channels. And the second limitation is that this is short-lived. So when you created that setup transaction, you also created a refund transaction. So you say that, okay, if the coffee shop dies or he goes away or he runs away for like whatever reason, I can broadcast this refund transaction and I will get my money back after X time. So this can be, and you use it using a simple simple opcode called object lock time verify. So it's an absolute time lock that you place on a transaction level basis. So I'll explain why this is important as this is used later on. But so you basically say that this transaction is going to be valid 1500 blocks from now. So you can broadcast it. It's going to be in the mempool. It's never going to be included in a block until that particular block height is reached. So this means that you've established basically an upper bound on the limit of on the life of the channel. So if you say like the life of the channel is 1 week, and after 1 week, if you're still continuing to exchange these commitment transactions, you can cheat the coffee shop by by redeeming your old transaction and getting all your money back out of the multi-sig output, and thereby defeating the entire purpose of the payment channel. So they're like two of the fundamental limitations of a unidirectional payment channel. So to solve for to exactly solve for both of these issues, there were two sort of two important opcodes that needed to be introduced into Bitcoin itself. The first one was object sequence verifier, and the second one was the inclusion of segregated witness, primarily because if you create a refund transaction prior to the setup transaction, this is subject to malleability. A transaction malleability is basically when you're able to change, you're able to change the output script by adding a simple opcode and thereby changing the entire signature and the transaction hash, but reusing the exact same signature that the user signed with. This was the reason. This was the claimed reason that Mt. Gox, one of the biggest Bitcoin exchange hacks, this was one of the reasons for why it happened. So we had to solve malleability for Lightning to actually work, and this new opcode object sequence verifier had to be included. What object sequence verifier does is, like object lock time verifier, like I told in the previous slide, like for a refund transaction, you put this on a per transaction basis, which is an absolute time lock. So CSV basically puts this changes that to a relative time lock. So it's relative to the outputs that you have in your transaction. So so this is very useful in the case of solving the previous two problems with the unidirectional payment channels, as you can now make complex outputs that can do many things that you couldn't do previously. So for example, let's take a simple example. So let's take the same transaction where I have a multi-sig output from myself, Bob, and the coffee shop, and I want to create a new transaction that has two outputs. One is giving one Bitcoin back to Bob, and the other one is saying the other output is basically a condition. So this is what you can do with Bitcoin scripts. You make a simple condition, and in that condition, you say that the coffee shop will get one Bitcoin if they sell, but they have to wait 100 blocks to get it. Else, this output is redeemable with Bob's private key and this new key that's called coffee R key. So anybody that can produce this, what this output does is now that this output is redeemable either after 100 blocks by producing the key of the coffee shop or the signature from the coffee shop, or this can be redeemed by Bob's key and this other random key. I'll explain to you what that other random key is. So now moving on to, so we're going to use this very simple construct to basically build up a bidirectional payment channel. So the two problems we wanted to solve for was, okay, how do you make money be able to go back and forth, and how can you do this for an infinite period of time. You don't want to have like 1 week channels or even 1 year channels. Like, so typically Lightning is designed in a way where you can potentially live off chain for the entirety of it, given that the entire network is actually on that layer. So when you set up the fundamental difference is you're going to use this op check sequence verify. So when you create a setup transaction in the exact same way. You basically ask the coffee shop, hey, give me a pub key, create a multi-signature address. You deposit some funds into this address, but it's not broadcast to the blockchain yet. And then you create your first commitment transaction, which behaves as your refund transaction. And the commitment transaction is going to look very similar to this transaction here that uses OpCSV. So you would basically be able to get your money back. You would be able to get this 2 Bitcoin that you put in back after a 100 log delay, or whoever has the key, whoever has this random R revocation key, it's called a revocation key. Whoever has this revocation key can combine it with their key and get all your money back. So this is the fundamental, like this is sort of one of the reasons I said that this is like very exciting is because it does not include. I mean, there's no. It's just a very clever combination of economics and incentives. Basically, it's trying to say that okay, if I do something malicious, if I try to steal money, or like if I try to publish an old state, I'm going to be punished by the coffee shop, and he's going to take all my money. That's what I want to prevent. So using that very basic construct again, now we can start exchanging commitment transactions in any direction. So I have this signed refund transaction that I can broadcast at any point in time. So this basically removes that upper limit on the life of the channel. So I can have a channel that's open for 10 years and not make any transactions, but this refund transaction is still valid because it's a relative time lock on the output itself that gives me money back. So in the other case, let's assume you make a channel with a coffee shop and you're going to actually keep buying some coffee from him from time to time. So let's say, like just to show you how this would actually work is the first time, let's say you buy 1 cup of coffee, you're going to make a new transaction that basically spends the same 90-second output, and you're going to update the output balances to 0.5 and 1.5. And these are going to have the exact same conditions as they had over here, like I showed you this. So in this manner, uh, what you're doing is you're creating a new transaction that has one output that goes to you, and the other output goes to the other person, but with a condition that says you have a small period of time, or somebody can punish you and steal all your funds. And what you do at this point in time is you exchange your revocation keys. So during every single transaction, you create a new public and private key pair. And the way this is done can be read in the both specifications. But so you basically create a new public and private key pair, and then every time you update the state, you reveal the private keys that you created. So if I try to, so after this one transaction, like obviously the previous transaction that has a 2 Bitcoin balance going to me is more favorable. If I try to broadcast that transaction, now the coffee shop knows this private key, this coffee or private key, that's the private key that I created. So they know that, and they can not only get their money back, but they would also be able to take all of my money. So this would prevent me from trying to cheat and broadcast an old state. So with that very simple construct, you basically removed the two fundamental limitations that we had that basically said that you can't have an infinite duration channel, and that you can't go in both directions. Now I can basically give them now we can shuffle the balances between each other in whatever direction we feel like, because we continually provably delete our old states, and this creates a bidirectional payment channel, right? To actually give you a little bit more insight into exactly what these transactions look like is every single time you update your channel state, what you're doing is you're exchanging commitment transactions. You're exchanging commitment transactions, and you're exchanging these revocation keys, which is basically a regular private public key pair. So, for example, let's take the first transaction, right? So what's gonna happen is me as Bob, I'm gonna give a transaction to the coffee shop that says that, okay, hey, I've signed this transaction, now you can sign it, and if you broadcast it, what's gonna happen is I will get my 1 Bitcoin back, but you will have to wait 100 blocks to get your Bitcoin. And there's also this condition that if I have your revocation key, I can combine it with my key and get your 1 Bitcoin as well. So if the coffee shop tries to broadcast this old transaction, I can basically punish them because if we updated the next state, I have his revocation key and I can punish him and take all his money. So there's no reason that he would broadcast the old state. And the transaction that I'm holding as Bob is basically it's the exact same transaction but in inverse. So this is pretty much how bidirectional payment channels work. It's the fundamental premise for the Lightning Network itself. Now, this example took into account that okay, like I want to pay a coffee shop, and that's like if I want to pay this person, I have to be directly connected to them, connected to this person, and I'm going to make payments like it's only between me and him. Like, what if I wanted to pay somebody else on the network, but I don't have a direct channel with them? Like, I don't know, like, how do I create a channel with this guy? Because creating a channel takes time, right? Like, there's that one transaction that has to be set up on chain. So to explain that a little bit more, like that's how that's getting into Lightning in itself, is this very simple concept of time locked contracts, which basically uses the same output, but it's basically a very simple condition that's added to another output that says that this output is spendable by anybody that can produce the pre-image of a particular hash. So it's basically like saying, if you have a it's like saying that if you know the secret to this hash that's encoded in this output, I can spend this output immediately. Otherwise, this output is going to come back to the person who it's going to come back to the person whose pub key is written in that output after that lump time that's specified in CLTV or CSV. So using the simple concept of HDLCs, we begin to construct what the Lightning Network actually looks like. So now let's take the case where I want to pay this coffee shop, and I do not have a direct channel with this person, but I don't have the time to set up a channel with him. I'm just in the shop, but I'm a participant on the network, on the Lightning Network, and I have a channel set up with somebody else like that. That may be anybody. So let's say I have a channel with Node 1, and I want to pay this coffee shop 1 Bitcoin for my coffee. It's pretty expensive coffee, but yeah, that's what I want to pay him, right? So what I'm going to say is, hey guy, I want to pay you 1 Bitcoin. Give me a way to pay you. So what the coffee shop is going to do is they're going to create a random number R, and they're going to send me the hash of this random number R. And R is secret. The coffee shop would never reveal it. So I'm going to take this hash of I'm going to take this the hash that the coffee shop gives me and use it on my channel. I'm going to construct a HDLC to the first node saying, okay, I need to pay this guy 1 Bitcoin, and I'm sending you a HDLC that's worth 1.002 Bitcoin. And what I'm doing, so there are a few things that are happening here. Like, this node 1 does not know that this money is going to the coffee shop. The only thing that node 1 knows is that somebody is asking me to forward a payment to the next node, that's node 2. And in exchange for doing this, I'm going to get 0.001 Bitcoin back. So as you can see, the difference between the HDLCs is 0.001. So being a node on the network basically gives you a small reward for forwarding payments. And this significantly increases privacy, because at no point in time does any node know where the payment is coming from or where the payment is going. Every single node just knows that somebody is asking me to send a payment, and I know where to send it next. In reality, the only person who knows the entire route is the person who is making the payment itself. So I'm going to forward this HDLC to node 1 that has 1.002 Bitcoin, and node 1 has a channel with somebody else, let's say node 2 in this case. And he's going to forward that HDLC. He's going to create a new HDLC using the hash that I sent him, and create a HDLC for node 2 that spends a slightly smaller amount because he's taken some of that money as fees for himself. And then node 2 basically does the exact same thing and passes it on to the coffee shop. Now, again, the important point to note here is that node 2 does not know that the coffee shop is the recipient. They are simply just relaying transactions. So at this point in time, the coffee shop realizes, okay, cool, I've got my payment, I've got my 1 Bitcoin payment. And what the coffee shop will do is they will reveal this secret, or this random number, basically. They will reveal it to node 2, such that node 2 can redeem the funds that was locked in the HDLC because they knew the hash. And that's basically the sort of fundamental premise of the HDLC. If you know the secret that's R, you can redeem that out. And then node 2 basically passes that HDLC on back to node 1 and back to me. So once I have my once I have this secret in my possession, that's sort of like the receipt for my payment. So what this is actually called is basically an invoice and a receipt. So like in traditional finance stuff, right? Like, so the coffee shop generates an invoice that has this hash encoded inside it, and when I make a payment, once the payment is completely successful and routed, I get back the pre-image that tells me that, okay, this is a receipt for my payment and my payment is successful therein. So this is all like the fundamental basis for the entirety of how Lightning works in itself. So as you can see, there's like a lot of different problems. Like, this is a very simple example of just 4 different participants, but just imagine a very complex network of thousands of individuals and thousands of nodes with channels between each other. So like, some of the big problems are with routing payments between nodes. You may not always find a route that has enough balance, and so on and so forth, basically. So that's like sort of how the whole thing works. Moving on, that's pretty much like an overview of Lightning, and I'd just like to talk a little bit about like why this is exciting and what sort of opportunities there are. So as you can see, like, this is super nascent sort of technology. It's been under development since, I think, 2015. So it's been a while now, but only 2018 did Lightning actually go on mainnet, or people could actually start making these instant Bitcoin transactions off chain. But there's still a long way to go. So it's sort of like, again, if you actually try to compare it, it's a little bit like how Bitcoin was in 2009 to 2012. Like nobody knew what it was. It was this complex thing where all the wallets were these command line interfaces, and like, it was this very complex stuff, right? So Lightning is sort of in the same place, which actually opens up a huge list of opportunities for people to develop different products and different services or whatever you want to develop on it. Admittedly, it's a little bit harder to develop on Lightning as opposed to, let's say, Ethereum or Solidity, just because of the nature of the language that's used and sort of the fundamental underlying constructs that you need to understand to actually make a good sort of product out of this. So one, like, so I just walked down this quick list that I thought of off the top of my head. So one very cool thing that you could do is with this sort of with this very simple concept of HDLCs and routing payments, you can actually connect different blockchains together by basically making. So just imagine the context where you go back to this example where I as Bob is connected to, I'm connected to Node One, and Node One, this may be one of you people that basically have accounts on, like, or you use other cryptocurrencies, and you have addresses and wallets that contain money in different wallets, right, on different blockchains, right? So what you could essentially do is forward a HDLC onto a different network. So for example, I'm a Bitcoin user, and the coffee shop only wants, let's say, Ethereum. In this case, if Node One was an Ethereum user, they could potentially sort of create this cross-chain HDLC that would pay the coffee shop in Ethereum, and they get paid in Bitcoin. So that's a very powerful use case to actually create something on top of like many different blockchains altogether, and that can actually be done very elegantly with Lightning, and it's pretty mature in doing that. And it's not just for payments and coffee shops, but of course you can also use it like in the context of Bitcoin exchanges, that where people want to hold on to their funds and hold on to their keys, but be able to convert it into various other cryptocurrencies without, I mean, instantly and pretty easily. So that's how, I mean, those are like, that's one possible opportunity. And of course, the more obvious one is micropayments in themselves. Like this is like, for me personally at least, it's like the reason it's super exciting is because, like, literally for the first time in the history of electronic money, like two people can exchange value without any sort of centralized third party, and nobody can shut them down. Like there's no, and this is like sort of the fundamental difference between this and most of the shit coins, that where you can actually shut things down. I mean, and it's not, it doesn't have many of the intrinsic properties that Bitcoin has. Not to say that they will not achieve these properties in the course of time, but as of today, as it stands, this is extremely exciting to be able to create these micropayment use cases with Bitcoin that just were previously impossible. Like you literally could not, like 1 year ago, you could not walk into a shop and, like, you can't actually buy coffee and pay for it without Lightning, right? You'd have to wait 1 hour for your confirmation. So this enables like a very powerful use case, and that's sort of what Lastbit's focus is also on. And of course, the more important ones are to actually enable like the sub layers of being able to enable these micropayments is our wallets and node operators. So as you can see, it's not the most trivial thing to actually use. And as of today, it's relatively complex for end users. And being able to create a kick-ass user experience, or being able to create something that sort of brings Lightning to the end user in a way where they don't really have to understand any of the stuff underneath, is something that's extremely powerful and not been done yet. Like there are quite a few Lightning wallets out there, including ours, but you see that they still have a long way to go before they're like very ready for the very ready for the masses. And node operators, in the sense that a lot of people, like let's say like the most average consumer doesn't really understand these mechanics and don't understand how nodes actually work. So in the same way, when you today if you're broadcasting your Bitcoin transaction, you probably use a third party service broadcaster, like you use blockchain.com or Lopcipher or whatever it is to broadcast your transaction, right? So there's still a massive potential for node operators to operate Lightning nodes for on behalf of other users in a trustless manner. So that's something that's extremely exciting as well. And the last two are relatively smaller use cases, but as Lightning actually does take off, and I like to mention that like Lightning is, it's not like a cool concept or an idea that nobody's used. There are actually like about 10,000 Bitcoin nodes, full nodes out there, and there's about 12,000 Lightning nodes. So it's actually grown a significant amount since the last 2 or 3 years, when it's actually become more and more mature. But it's still like very focused on the developer community. But you can imagine that once it goes mainstream, like the same way hardware wallets like a Ledger or Trezor solves the problem for holding your crypto today, you would need some level of hardware security for your Lightning nodes, primarily because this is a node that's going to be always online and exposed to the internet, right? So having an additional level of security for that is something that can be a potentially great opportunity as well. And the last one, Light nodes, is it goes in tandem. It goes in tandem with hardware security for Lightning nodes, basically because you're not gonna, like, every Lightning node requires you to also run a full Bitcoin, primarily because it's layer 2 and you need layer 1 to verify your transactions, and that's not really feasible for commodity hardware. So being able to create, there are many proposals and many ideas for this already, but actually taking that and trying to create sort of like an SPV wallet for Bitcoin, like a simplified payment verification version of Lightning, where you essentially store only the channel secrets and your and HLT pre-images on your own hardware device, but the rest of it is online. So you sort of secure the most important part of Lightning, but the rest of it can still be on commodity hardware. That's another like high level protocol level thing that you can look at to build something cool. But that pretty much brings me mostly to the end of my presentation. I think I went quite over time. I was going to show you guys like a quick demo of how you can set up your own development environment for Bitcoin and Lightning, like on a reg test mode and pay some invoices. But I'll save that for a later date. I hope you guys want to learn more about this stuff. So that's it from me. And if you guys have any questions, I'd be happy to answer them.
Yeah, great, Prashant. That was a really good session. So we have a few questions. So the first one is, why aren't many people using Lightning? There are less than 1,000 Bitcoins on Lightning versus 10,000, 11,000 Bitcoins that are on as ERC20 tokens on Ethereum. So why are more like Bitcoins not locked up in Lightning?
So it's actually a very good question. So Lightning, it only started taking off only about a year ago when it really went on, like people could actually start using Lightning on mainnet only about a year and a half ago. And the reason that you wouldn't lock up a ridiculous amount of Bitcoin is primarily because one of Lightning's primary use cases is for micropayments. You're not trying to make thousands of dollars of payments on Lightning. If you're doing that, you'd be better off doing it on chain. Right? So it's mostly targeted at it's mostly built for rapid micropayments. So like buying $1 coffees, or like you can pay like 1 cent. You can even pay pennies for like close to zero fees, and that's sort of the main use case today. That's like one of the main reasons. But the other reason is also because it's really difficult for people to get like the Lightning user experience is so far from maturity today that not like most end users still do not understand how it works and how to actually get started with it without having to understand any of the risks. Much like unlike other ERC20 tokens that basically have like a big marketing team behind them, Lightning does not have this, and there's not that many. Let's say that's I think that's actually a massive opportunity to be able to create a kick-ass Lightning user experience.
Yeah, makes sense. So the next question is, could you explain more about how multi-sig wallets and addresses work?
Sure. So multi-sig addresses are like it's actually very simple. It's basically like in most cases, you would assume that you would create a multi-sig address in a friendly sort of manner, like where you're basically using it to create some sort of security, like say, let's say between you and your friends. Like I have 5 Bitcoin. I don't want everybody to I don't want to lose the security in my wallet, so I'm going to call 4 of my friends and say like, hey, all 4 of us need like every time we're going to lock this Bitcoin up in this like joint account, and if I want to spend it, I'm going to need to get all your permissions before I can do that. That's like usually how multisig works, just in a friendly manner. But in this case, for Lightning, you're going to assume adversarial multisig. Like you're basically creating a joint account with this random person on the internet that you've never met before. So how the way it works is actually very simple. You use existing Bitcoin opcodes. Is like the only difference is there in the output script is instead of object sig, you put object multisig, and you include the public keys of the other people that are involved in your multisig transaction. So you basically take somebody's public key, you take your own public key, you put that together, and you create a new address that people can deposit funds into. But spending that output would require 2 signatures instead of one. That's pretty much how it works.
Okay, cool. So we have one more question from Harshad. In HTLC-based multi-hop payments, how do we know how many nodes we have to pay for the fees?
Sorry, your voice broke up a little bit.
Yeah, I'll repeat the question. In HTLC-based multi-hop payments, how do we know how many nodes we have to pay the processing fees?
So when you create so because how it works is you create like the person who's making the payment creates an onion routed HTLC. So there are a couple of layers to this onion, and you get to like as a payer you get to pick the route. The Lightning client itself will suggest a route for you, but it's completely your prerogative to choose the route that you want to pay. So there may be 5 nodes in between, there may be 2 nodes in between. You may have a direct channel with them, but the sum of the entire fees is basically is calculated based on the route that you have, and each node can set their own routing fees. And the Lightning client in itself would pick nodes that don't have ridiculously high routing fees, basically. So you would basically try to include once you figure out the route that you want to pay it, you'll be able to get the fee rate for each of the nodes on your route, and you would include in the amount that you're trying to pay the sum of all these fees.
Okay, awesome. So one more question from Harshad. Can we add more Bitcoins to an existing channel after payment channel is set up?
Yes, you can. Not as of today, but that's something that's work in progress. You'll be able to splice in funds. It's called that's what it's called. But I suspect like by the end of the year you would be able to. And the same goes for dual funded channels. Today you can only fund channels from one direction. Like I can only lock up Bitcoin, but the other person can't put in any Bitcoin. But these two things sort of go hand in hand, and that's something that's being very actively worked on among other things.
Okay. So last question by Harshad: is there any fees for using Lightning payment channels?
No, there are no specific. I mean, there's no. It's not a company that you pay fees to or anything. It's basically the fees that you want to pay and as much as you want to pay. So the only fees that are involved are in creating that setup transaction. So when you put your Bitcoin into that multi-sig address, you have to pay the regular mining fee that you pay for broadcasting any Bitcoin transaction. And then when you make a Lightning payment, you're basically including these small fees for the people that are involved in the hop. But those fees are like they're ridiculously tiny. Like it's a few satoshis basically. Like so you can send like a 1 cent payment for like 1 penny basically. But that's as of today. These fees are supposed to increase, or like they will increase as there's more demand and stuff like that. But that's pretty minimalistic.
Okay, awesome. So with that, I think we have pretty much run out of time. Thank you so much, Prashant. This was an awesome session on Lightning. Yeah, you have any closing remarks? Where can people reach out to you?
Um, I mean, you can send me an email from our website. I don't really have a big social presence, but I guess the closing remarks would be like this is probably like one of the most exciting things for that's happening for Bitcoin, and it's one of those things that's not going to go away. So I mean, like Shrikar said, like India has like this fantastic developer base and developer community, and I would encourage a lot of you guys to actually take a look at it and try to build some cool products on top of it because there's just like so much opportunity as you can see. Like it's so nascent, like it's very basic, and building anything is going to be. I mean, building something useful is going to be a big step for not just Bitcoin, but for, I don't know, from coming from India as well.
Yeah, for sure, man. So yeah, with that, we conclude this session. We'll be back with the next session in a few minutes. So guys, you can take a break, you can network, you can have a cup of coffee. Awesome. See you guys.
So yeah.